So, dear colleagues, we are continuing with our series of chemical kinetics concepts, and here we are talking about rate of reaction. So, the rate of reaction or the reaction rate is the speed at which a chemical reaction proceeds, and it is often expressed in terms of either the concentration or the amount per unit volume of a product that is formed in a unit of time, or the concentration of the reactant that is consumed in a unit time. So we are talking about the rate at which products are formed or the rate at which reactants are consumed. So that gives you generally the rate of reaction. So if we consider, for example, consider a reaction such as A that is reacting or decomposing to give us products. Okay, if it gives us a product, for example, P. Now, if we want the rate of reaction will be the rate at which A or the reactant M is disappearing. So if it is disappearing, we shall say it is D concentration of A, okay, with respect to time. And this is equal to, we can as well say, is the rate at which the products are formed. So the products are increasing, so that's why it is a positive, whereas the concentration of the reactants are the concentration of reactants is reducing. That's why we are representing it with a negative a negative derivative with respect to time. So once we do that, we find that this is equal to K times concentration of A, depending on the order of the reaction. For example, if we are talking about the first order reaction, then the reaction rate is going to be like this. And we are going to find that it is always, once we are talking about the rate equation, where rate is equal to concentration, K times concentration of A. Maybe let us put, okay, let's leave it at that. So we shall say this is representing the concentration of A in moles per decimeter cubed or per liter. Then K is what we call the rate constant. So we have to understand that, and obviously the rate constant is its units are derived from that equation. And in general, if we have a reaction that is composed of A, okay, and it is having A molecules, so we have B giving us C plus D. Now, the rate of reaction for this rate here is actually going to be 1 out of A negative, the A, or times the concentration of A, okay, divided by dt. This is the same as negative 1 out of B times the concentration of B with respect to time. Then this is equal to 1 out of C times the C capital divided by dt. This is 1 out of D times times d, okay, this is the concentration of d divided by e. So generally you can see that as time goes by, the reactants are decreasing in amount, whereas the products are increasing in amount or in concentration. And then the other aspect that we need to talk about is the fact that if we want to determine the order of the reaction, so the reaction here, we can see that it is majorly depending. Okay, if we want to write the rate equation for that, rate equation for for the above equation, we can say that the rate is equal to K times A times B. So we're talking about reactants here, okay, not products. So the rate equation, you must note that the rate equation is always in terms of the concentration of the reactants, okay, not the products but reactants. So what is okay, we had earlier on said that this is the rate constant. Then obviously this is the concentration of reactant A. This is the concentration of reactant B. And X is the order of reaction with respect to A. Then Y is the order of reaction with respect to B. And so if someone asks you to determine the order of reaction with respect to A, then you would write X. If someone asks you the order of reaction with respect to B, you'd write Y. So the overall order of reaction would be X plus Y. So I would add the powers to which the different concentrations of the reactants are raised. So the order of the reaction for this particular reaction, if this is the one, okay, it would be X plus Y. Remember that X and Y are not determined by stoichiometry, but are determined by experiments. So an experiment is carried out to determine X and Y. And what is stoichiometry? That's why you see here in this reaction, we have A molecules of A, B molecules of B, okay, giving C molecules of C and D molecules of D. But these are not being seen in the rate equation, as you can see. We have instead X and Y, but we don't have A, B, C, D. So stoichiometry is talking about how much of molecules or moles of A are reacting with how much molecules of B. Or for us to have this equation take place, how many moles of A are required, okay, and how many moles of B are required. That is stoichiometry. So, and obviously stoichiometry itself, maybe if you wanted the definition, we are looking at a stoichiometry of a reaction obeying the quantitative relationships. So we can say it refers to the quantitative relationships, okay, of the amounts of products, and reactants in a given reaction. So that is what stoichiometry is talking about. And as we said, The values of x and y, values of x and y are often 1 or 2. They can be 1 or 2 and rarely 0, okay, 3, a fraction, and even a negative. So we rarely find this x and y, or x equal to 0, y is equal to 3, being a fraction and negative. These are rare cases. So we have seen that the order of the reaction has nothing to do with the stoichiometry of the equation for a given reaction. Now, I want to give us a simple reaction. So let's look at a simple reaction, between bromated 5 ions, bromide ions and hydrogen ions to give bromine, and hydrogen ions to give bromine. Now, the equation for the reaction is as follows. So we can have the bromated 5 in aqueous form plus bromide ions plus hydrogen ions, okay, giving us bromine plus water. So now our task is to actually do the what? Do the balancing. So we can put a 5 here, and bromine becomes 6, so we put 3 here. So what is here? This is 3. This other side we have 3. We have 1, so we can put 3 here, and then hydrogen becomes. So that is one simple reaction in which bromated ion, bromide ion and hydrogen ion react to give bromine. And in such a reaction, you find that when we write the rate equation, it does not represent anything to deal with the stoichiometry of this equation. So when the experiments were carried out for this particular reaction, this is the rate. So rate, obviously, will equal to negative. So which reactants do we have? We have the bromate. So by dt will equal to negative. So the concentration of bromide ion by dt is equal to negative the concentration of hydrogen ions, and this is equal to, obviously this should be equal to the concentration of bromine, okay, and then we are going to say the rate equation is going to be, so you find that also rate is going to be negative the bromate 5 ions with respect to time will equal to K times the concentration of the reactants, which is obviously the bromate ion, times the concentration of bromine ion times the concentration of hydrogen ion. And you find that this hydrogen ion carries 2. So you find this is a complex rate equation. So what could be the order here? So order of the reaction here, order of the reaction. So what is the order of the reaction? gas. So this is going to be, you see, it is order 1 with respect to the bromate 5 ions, and order 1 with respect to bromide ions, and order 2 with respect to hydrogen. So what is it going to be? Order of reaction, we're talking about overall. So the overall will be 1 plus 2, and this becomes 4. So this gives you a fourth order reaction. So this is a very important part that we needed to cover to give you a hint on what is the order of the reaction, what is how do we write the rate reaction. As we said, rate of the reaction, um, of course, which gives us the rate equation, does not include the products, but it includes the reactants. So never express or never write the equation of the rate of these reactions and you give it in terms of products, but give it in terms of reactants. Then we have also looked at how we determine the order of the reaction. Then and basically how we generate those equations given a reaction that is giving us the composition of reactants, giving products, and also where you have a number of reactants giving you a number of products. So we're going to be looking at factors affecting the rate of reaction in the next discussion. Thank you so much.